Hello everyone, in this video we will solve the question 287 in the LeetCode, that is find the duplicate number. So in this it is a medium level question. So we are given an array numbers containing n plus 1 integers where each integer is between 1 to n inclusive. That means we are given spaces of 1 to n plus 1 and we have numbers only from 1 to n. So we will be left with the extra space. So we will have to repeat a number from 1 to n to fill that place. So we have to prove that at least one duplicate number must exist. Assume that there is only one duplicate number, find the duplicate number. So we are to assume only that only there is one duplicate number because only we have one extra space. So in this array, that is 1 3 4 2 2, we have 2 as a duplicate number. All other are only occurring single time. So in this also 3 is repeating. So we must not modify the array, and we must also only use the constant extra space, that is O of 1, and our run time complexity should be less than O of n square, and there is only one duplicate number in array, but it could be repeated more than once. So 1 may be repeated more than once, that is if 2 is occurring 2 times, it may be repeated 1 time more, that is 3 times. So we will see this question step by step. I will show you the approaches that we will if we are asked in the interview this question, if we are asked, then how we need to approach to it. So first of all, we will start with the brute force approach. That is, if we are given this array, so the brute force approach that comes to our mind is using 2 for loops. So that is really brute that you can understand yourself and tell the answer to the interviewer. So he will tell you to optimize this approach. So you may say him that in this array, if we sort this array, this is array, so basically we are given 1 3 4 2 5 6 7 2, so 2 is repeating, so our output should be 2. So we will sort the array first of all, then we will iterate over it and check if one element is same to the element at next index. So we will check if 2 is equal to the I plus 1 index, element at I index is equal to I plus 1 index, and it is a repeating element. So as we have sorted the array, all the repeating elements will be coming together or continuous. So as we have sorted the array, all the duplicate numbers will come together. So it will take n log n time to sort the array, and O of 1 space or O of n space accordingly if you use merge sort or quick sort. So that was it for this solution. So interviewer will tell you to optimize the time complexity. So so for optimizing the time complexity, we can use a visited array. So basically we have to initialize a visited array of same length, so plus 1, so because we are not getting element from 0 element 0, so we are getting elements from only 1 to n. So 0 index will stay as it is, we won't touch this index or use this. So we have to initialize a visited array with all zeros, then we will traverse our original array without sorting anything. So we will traverse over it and we will check if 1, so we will go to index 1 and we will check if at index 1 the value is 0, so it has not been visited, so means we will set it to 1. Similarly at 3, we get element 3, then we will visit to the third index and we will check if it is 1, no it is not 1, it is 0, so we will set it to 1. And similarly all these will get 1 when we visit them accordingly, and then when we have got all the elements, so basically they are continuous, so nothing is missing between them, but only one element is repeating. So we have got all. Now when we visit to 2, so we go to second index, so it is 1 before only, so means it is a repeating element, it has been visited before only, so we can say this is the repeating element. So basically here we have improved our time complexity, but our space complexity has increased. So we are taking O of n space for creating this visited array. So the most optimized approach, or a really good approach that I would say, is using a slow and fast pointer concept that we would have studied in the linked list. So basically, as you know, we have studied this slow and fast pointer in the linked list to detect a cycle. So basically we will form a cycle using this array. So I've written the original array here. This is the array 1 3 4 2 5 6 7 2. And these are their indices, that is 0 1 2 3 4 and 5 and 6 7. So we will this I have created only for the intuition. So we will build this linked list like structure actually. So I will show you the approach then. So basically I have made this using first we will use visited array, then first element is 1, so we will write 1, and now to find out which element will be next to 1, we will go to the first index, that is this 1. So next element is 3, so we will write 3, so 1 will point to 3, and similarly third index contains value 2, so 3 will point to 2, and second index contains value 4, so 2 will point to 4, and then we will go to fourth index. So fourth index contains value 5, so we will go to fifth index. So now we will go to fifth index, it contains value 6, so 5 points to 6. Now we will go to sixth index, it contains value 7, so 6 will point to 7, and seventh index contains value 2, so which has been visited. So it will it will make it will end into a cycle. So 7 points to 2. So this you can see we have formed a cycle. So basically we will use now linked list approach, that is using slow and fast pointer. Slow pointer, as the name suggests, it will move only one, it will only jump once, and fast pointer will jump twice in a single iteration. So we will initialize the slow and fast pointer at the first position. Now I will first of all iterate the slow pointer, then the fast pointer. I will jump first slow, then fast. So slow will come here, and fast will come from 1 to 3, then 3 to 2. Fast will come here. Now our slow is here, so slow will come one position ahead, so 3 to 2, and fast pointer was here, so it will jump from 2 to 4, then 4 to 5. Fast pointer will come at 5. Now our slow pointer will come from 2 to 4, that is at this point. Now fast pointer will jump from 5 to 6 and 6 to 7, at it jumps 2 steps. So now our slow pointer will come here, that is 5. Now our fast pointer jumps 2 steps, so it will come from 7 to 2, then 2 to 4. It will come here. Now our slow pointer will come to this point, that is 6. So it has came here. Now fast pointer will jump from 4 to 5, then 5 to 6. So basically at this point the both pointers collide. So basically 6 is a collision point, as fast pointer is moving 2 times the speed of the slow pointer, so it has also covered the twice the distance of slow pointer. So they are bound to like meet in this loop. So basically if slow pointer is moving 1 time in this, so fast pointer will move 2 times in this. So for understanding this, so first of all I will show you the approach. Then when we have found a collision point, then we will again initialize. So one while loop has ended when they have collided. So now we will set the fast pointer to the first index, that is 1. So it has come here. Now the both pointers, slow pointer is at the collision point only, and fast pointer is at the first index, so at the starting point. Now they will move one step, one by one. So slow pointer will come to the next index, that is 7, and fast pointer will come from 1 to 3. It occurs in same iteration because they are moving one by one at same time. So now fast pointer will come to the next point, that is 2, and the slow pointer will also jump from 7 to 2 as it forms a loop. So at this point both again collides. Now they have traveled equal distance. You can see from 6 to 2 there was one node in between the slow pointer and the starting of the linked list, starting of the loop. So the fast pointer also traveled 1 to 2, and there was only one node. So this distance is equal. When we have found this, so you can understand this using you can refer to the YouTube for this. Basically it is called a Floyd's algorithm, so you can check it how it works, how it is proof that it will surely work. So you can check, there are many videos for the explanation. I will keep it simple because we are not understanding the linked list approach. So actually when these points combine, so we will return the slow pointer value, that is 2. So we have actually found the repeated element. So I will show you how we can implement this without using a linked list implementation or converting the array into a linked list. So we will basically use this approach, that is we will set the fast is equal to, first of all, fast and slow, and both will point to the first index. So slow will move by one index, that is a of slow, array of slow, and fast will move to array of fast and fast again. So it will jump 2 times and slow will jump 1 time. You can understand this by like writing on a paper. So I will show you the dry run of this array specifically. So we have initialized slow and fast pointer to the first index, that is array of 0 and array of 0. Both are at 1 and 1. Their value is 1 and 1. So now we will move both by both in the while loop. Now when slow will move, so array of 1. Now we will use the element as index. So array of 1 is 3. So it will come out to be 3. Now for the fast it will become array of 1 and again array of 1. So array of 1 is 3. So it will come out to be 3, and it will go to the third index that has value 2. So ultimately the value will be 2. Now again they are not equal, so we will keep them running while they are not equal. So now slow pointer will again we will use it as an index for the another element, that is array of 3. So it is 2. So it is 2. Now slow pointer will move so to this index, that is array of 2, it is 4, so is equal to 4. They are still not equal, so while loop will keep running. Now we will use this as an index, so it is 2. So array of actually I did something wrong here maybe. Actually when I ran this, just a second, so it was array of 2, then we have to run it again. So array of 2, it jumps 2 steps, so array of 2 is 4, so it will go to the 4th index, that is value, it is having value 2. So 4th index actually, and it is having value 2, so they both have collided, so we have found a collision point. So you can rewind the video and check how I did that, and I did a silly mistake, so I showed you how it works. And now when we have found a collision point, it is actually repeating, but it won't be in every case that we found this elements as equal. So actually we will get sometimes a different value. So now we will have to do one thing, that is we will initialize fast again to the first point, that is fast will be initialized to this starting index, so it will start running by one step. Now fast will for this it will run only one step. Now in second loop, actually just a second, it is here. Now what's happening, we have printed. Now fast will only run one step and slow will also run for the one step. So now we will check when they get equal. So here slow of we will use 2 as an index, so its value is array of 2 is 4, so it is equal to 4, and it is value 0 1, and then array of 1 is 3, so value is 3. They have they have ran for one iteration. I will erase this so you can keep the count of the iterations actually. So now we have done this. Now it will again run a of 4, that is the array of 4th index contains value 2, so it is equal to 2, and array of 3, that is this will be used as index, so array of 3 also contains value 2. So now they have again collided, and this is our point of loop, that is this is where our loop occurs or starts. This is a repeating element, so we will return our value, that is we will return the slow pointer value or array of slow. So basically we have you can see how we have found the repeating element by using linked list method, that is using fast and slow pointer, or you can say tortoise and his algorithm or method. So this was how I showed you the dry run, and this was the loop. So actually you for the intuition or for the how proof of this algorithm, how it works, you can refer the YouTube video, or if you want to me to make the video, it will get actually bigger longer video, so you can just comment down below. Now I will show you the code on the LeetCode platform. So I have written the code in C++. So this is the code actually. So this is the code. So basically, just a second, what's happening? So we are given an vector of numbers, integers, okay, numbers. So we will initialize slow to the number of 0, that is first index of first element, and fast also to the first element. Now I have used a do while loop. So while it will run till while slow is not equal to fast, it will keep running. So slow will move by one index, one jump, or you can say number of slow, and fast will move by 2 jumps, that is number of fast. So I have shown you the dry run, so you can rewind the video and check out how it works if you have not understood. So then we will, when we have found a collision point, this is where we find the collision point. I will comment that in this loop we will find the collision point, and so we will find the collision point in this loop. So it is basically, now when we have found this, so we will set the first initialize first again, or fast pointer again to the first index. So we have initialized it, fast will be initialized to the starting point. So now both pointers will move by one step each. Slow will be at the collision point and fast will be to the starting point. Now slow will move till the fast, they are not equal, so slow and is equal to numbers of slow, and fast will also move one or it will jump only once, that is number of fast. So when they will be equal, then we have found the repeating element, that is we will return slow or we can return fast, whatever. Now I will show you the running this code. So yes, it works. So let's submit the solution. Let's see. So yeah, you can see it is faster than 97.67% of solutions, and it takes also less memory. Again we can try submitting it, maybe it increases the time complexity more. And Okay, you can see the space complexity improves. That is, it is using less memory than 71.14%, 14% of solution. And this was the code for it, and I will provide you the code in the description. So if you like this video, because I made this, I invested a lot of time making this video and like studying for it. This was a really intuitive method. I also liked it most. If you tell this method in the interview, then he will be also impressed, because you are using a linked list concept into an array, and you are implementing it without using linked list. So that is really a nice solution. So I explained you all the 3 approaches that you can approach. There may be more approaches, but I will only try to keep this video concise and accurate for the interview purpose. So thank you for watching, guys. Do like this video and subscribe this channel for more videos. Thank you for watching, guys. Thank you.